Hi everyone, so today we are going to do this easy problem called non-constructable change. So it is very simple. All you have to do is you're given a set of coins, that is a set of positive integers, and you need to find the minimum amount of change possible. So for example, in this one, here we can the minimum amount of change you can't create. Sorry, you need to find a minimum amount of change you can't create using this coin. So for example, here you can create one, you can create two, you can create three, but you can't create four. So you need the output must be four. So and that's what you have to do. And if you're given no coins, you can't create. If you're given an empty array, you can't create one rupee. So one has to be given. So you need to find the minimum amount of change possible. So for example, if we go here, you can create a value of 1. You can create value of 2, 1 plus 1 2, and next you can create a value of 3, and next you can create a value of 4, and next 3 4, and you can create a value of 5 3 4 and 5, but you can't create a value of 6. So similarly, if we take for this example, so you can create 1, right? You can create 2, you can you create a 3? No, you can't create 3. 1 plus 1 is 2. So 3 must be the output. So the output must be, so the output for this case will be 3. So how would we go about doing this one? So the brute force approach would be through going to each of these coins, and then coming up with all the permutations and combinations and checking if that value comes up to 3 or not. So you can try that out, but it's very complicated. So we'll be traversing there so many times, and it will be inefficient. So so is there an easier solution? Yes. In fact, the solution, the easiest solution is more simpler. So what do we do here is, first thing, whenever we get the coins, okay, we need to sort it. So they might give an unsorted array, so you just need to sort it. It has to be in ascending order. And the second thing is, when you get, so for example, what you have to do is you need to find the C over here. So you need to find, so just type it. So you need to find change is equal, you need to define change. So a variable called change, and next need to find, need to create this value called change. So each time you're iterating, you need to keep adding this one. So initially it will have 1, next it will have 2, next it will have 4 5 6, 4 5 6, so next it will have 6 or something like that. So the trick here is, whenever you whenever you're iterating, okay, you come across this new coin. So initially you'll be iterating, you'll come across an, 2, so you'll get 2 over here. Okay, so next, whenever you get a new coin, okay, you should check if you should check if this new change, to make this, Sorry guys. So how to make this go away. Okay, so leave it. So what I'm saying is you need to, whenever you get a change is equal to 2, so in relativity you got change is equal to 2, so whenever you can't, so whenever this number 4, this, so you got change 2 and then you see the number 4, so whenever you this new coin, so whenever this new coin is greater than this current change plus 1, then you can't form this change plus 1, so you need to return change plus 1. So that's it. So this is the trick. So whenever you check for a new coin, okay, now you got 4. Now can I can this is this new coin is greater than this change plus 1. So 2 plus 1 is 3. Okay, so yes, so this new coin is greater than 3. So we won't be able to form that change. So we need to return this one, change plus 1. So you can check it out for other example as well. So if it was 3, this condition won't get satisfied and we continue. So if we reach, so here we found this new coin and we broke out. So and we break out of the loop. So if we form for if we form for all the if we iterate through all the elements, so for example, if this one was 3, we iterate 1 plus 2, so we can form 1, we can form 2, we can form 3, we can form 4, okay, and we can form 5, okay. So see, in the end, if we iterate through all of the arrays, so for example, 1 1 1, let's take a simpler example. If we take through all the arrays, so all we are doing is we are adding everything. So we can form 1, we can form 2, we can form 3, but we can't form 4. So in the end, change will be having the value change 1 2 3, it will be having 3. So after that we come out of this loop, this condition never got satisfied, so we just return 3 plus 1 as the output. So in the end of the array, we just return 3 plus 1. So return 3, I mean, return change plus 1. So if we come out of the array, we just return, if we take all elements of the array, we just return change plus 1. So because we can't form, we can form 1, we can form 2, we can form 3, but we can't form 4. So that's it guys. So these are the these are the three main conditions. So first thing is what we have to sort, second thing is we have to iterate, and if at all we find a new coin which is greater than change plus 1, we return that one, or else we continue adding the sum, that is adding the change, and then in the end of the array, we after we iterate through all the elements, but if this condition is still not satisfied, we break out. I mean, we come out with the loop and then we return change plus 1. So this is how we are going to do it. So first step, like I said, we are just going to sort it coins. Okay, and the next thing what we are going to do is we are going to iterate. So for int coins. So if new new coin is greater than, so if coin is greater than, we will declare change is equal to 0. So change is 0. So if new coin, if this new coin, what this new coin is nothing but this one, if this new coin is greater than change plus 1, change plus 1, what we do here is return change plus 1. We return change plus 1. So if this condition is not satisfied, like I said, we just continue to add change. Like we just add, keep finding the sum. Change equal to change plus sum. So after this, we we try to throw all the elements. So in the end, we didn't. If this condition didn't satisfy in this case, we just return change plus 1. So in the end, we return change plus 1. That's it. Let's run this. Change is equal to change plus coin. Sorry. So yeah, that's it, guys. It's a good problem. Good to remember this. So yeah, and then the time space-time complexity will be n log n plus n. So space-time complexity will be n log n plus n, but we can remove this n because it will be like very small compared to this one. So n log n is because like we sorted it, so that's why we get n log n here as we sorted it in the very beginning, and then n because we did to each of the count, so it is in the form, so it is n. So but this n log n is a very big, will be a very big number compared to n, so we can just eliminate this. So time complexity will be n log n, and space complexity will be O of 1, like because like we are not storing anything new, like we're just storing one number and we're giving out that number, so it's b O of 1 space complexity. Yeah, so that's it, guys. Thank you for watching.